Okay, question 1. This question, it's all about speed time graphs. So the first part of the question just asks you to draw a speed time graph for the car and the motorbike. So we can see a car starts from rest at the beginning. So here is our time is equal to 0. We're doing a speed time graph, and here is our time axis. Starts from rest and it moves with constant acceleration for 30 seconds, reaching a speed of 15 meters per second, and then it maintains that time. We're then told that the motorbike accelerates at 1.5, when the car has been moving for 15 seconds, a motorbike starts. So that 15 seconds would be in here, and that means its speed time is doing absolutely nothing for the first 15 seconds, and then it starts moving. We can also see that the gradient of this part of the line, the acceleration, is change in y divided by change in x, just 0.5. So the motorbike with an acceleration of 1.5 is going to have a steeper line, and it's going to catch up with the car at some stage when the car has been moving for t seconds. So getting the graph right was really crucial to the rest of the question on this one, because part B then asks you to find the speed of the motorbike the instant it catches up with the car. Well, actually, the key thing here is that their displacements or their distances are the same. And the key fact you want to remember is that that means that the area under the graphs would be the same. So if we start first with the car, you could treat this as a trapezium. Some of you did and got that and did that well. I personally think it's a little bit easier if you just treat it as a triangle plus a rectangle. So my triangle is going to be a half base times by height. And then my area here is just going to be 15 times by this distance here is t minus 30. And essentially that's it. So we can just add those two together. This gives us 225 plus 15t minus 450, which gives us 15t minus 225. So that is the displacement of the car based on the variable t. Now we need to just think about the motorbike. So this one's a bit more straightforward. It's a triangle. However, we don't actually have this height up here. So we are going to need to use the fact that the gradient here is 1.5. So we know if we call this speed v, then we know that my change in y, my v, divided by my change in x, which this distance here is t minus 15, should be equal to 1.5. And that tells you that height there, v, must be 1.5 lots of t minus 15. That just gives you that height there. So when we now come to find the area of the triangle, so this is the distance, we're literally doing base, well, half base times by height. Well, that height we've already shown is that v, so that's 1.5 t minus 15. From there, it's just a case of setting up a quadratic. This simplifies then to 0.75 t minus 15 all squared. So we just set up a quadratic equating the two, and that leads us to t squared minus 50t plus 525 equals 0, which gives us two answers, one of 35, one of 15. Well, 15 is obviously when they both start from A and have no distance, so it's not that answer. And then final check back to the question. What's the question actually asking for? It's actually asking you for the speed. So you just need to sub that into this equation here. V equals 1.5 lots of 35 minus 15, which is 1.5 lots of 20, which is the 30 meters per second. Key things there is that for the collision to happen or for them to be at the same point, the distance, the areas under the graph must be the same. Other than that, the main mistakes were when we didn't get the graph right. Hope that helps. All the best. Bye.